This is 5.4. This is more graphing of trig functions. So the last lesson we covered sine and cosine, and I mentioned to you sine and cosine is the basis of graphing all of the trig functions, and the same as calculating many of them. So make sure you understand, one, the unit circle, make sure you understand about sine and cosine, the graphs of it. So as mentioned before, sine and cosine have period 2 pi, so cosecant and secant also have period 2 pi. So it repeats itself, that's what period means, it repeats itself every 2 pi. And again, I want to emphasize once again the unit circle. Make sure you know the unit circle. The main points that I have labeled there, and then some of the other ones will come in handy as well. So let's look at tangent first of all. So tangent, if you think tangent, one of the things you got to remember, sine over cosine is tangent. Okay, so we're going to be using that calculation. So if you look at this, remember this is cosine, sine, and if you literally think of tangent is sine over cosine. So look at 0 pi, so literally right at the beginning. So sine over cosine, so sine is 0, cosine is 1, so you're going to end up getting 0 over 1, which is 0. So the tangent is also 0 right here at 0 pi. Well, let's look at this one right here, pi over 2. Well, again, look at sine and cosine. Well, sine and cosine, remember this is cosine, this is sine. So sine over cosine would be 1 over 0, which is undefined. So tangent at pi over 2 is actually undefined. And the same thing, we can go around the circle to keep going around. So tangent 3 pi over 2 is also undefined. So over here is undefined as well. So you can do the exact same thing. I didn't mention this, but it's it's the same as when you do sine over cosine. So this is cosine sine. So you're going to get 0 on that one as well. So notice that it repeats itself every pi. So if you actually look at the graph of tangent function, so if you look at it, you can literally see 0. At 0 pi, it's at 0, and at pi over 2, it's undefined. So we have a vertical asymptote happening at pi over 2 and negative pi over 2. And to figure out the rest of the graph, you could look at like this point right here, which is pi over 4, which is square root of 2 over 2. You could look at that. So pi over 4, if you plugged in pi over 4 and negative pi over 4. If you plugged in pi over 4 and got the answer for that, again, sine over cosine, remember we're doing tangent, so sine over cosine, well, sine at pi over 4 is square root of 2 over 2, and cosine is square root of 2 over 2, so which is going to give us 1. So tangent is 1 right here. And the same thing if you did negative pi over 2, you would get negative 1. So you can see that just by graphing those 3 points, then you can see literally what the tangent function is going to look like. All right, so let's look at, that's the tangent function, and let's look at the other trig functions real quick. Now, you might want to just pause the video real quick and actually look at it and make sure you understand. We just talked about the tangent function. This is pi over 4, negative pi over 4. So that's the tangent function. And then the cotangent function, remember cotangent is defined as 1 over tangent. Cosecant is 1 over sine. We'll talk about that in just a minute. And secant is 1 over cosine. So something I want you to notice, specifically the cosecant and the secant functions. One of the things that's going to help you out tremendously, remember cosecant, let's look at cosecant. Cosecant is 1 over sine. So think of the sine function. Remember, sine function starts at 0, and then it starts going up to 1, and then it comes back to 0, and it keeps going like this. That's the sine function. And again, if you notice that at pi, because again you have, notice it's at 0 and here, so there's a vertical asymptote there as well. So the reason why it's undefined is because at pi, again, think of the unit circle. So at pi, this is -1, 0, and this is 1, 0. So notice at 0, at 2 pi, at pi, the sign is 0, and you can't have 1 over 0. So it's undefined at 0, at pi, at 2 pi, at -pi. That's why there's a vertical asymptote at cosecant. Well, the same thing again, you can literally just plug in, this is 1, 1 over 1 is still 1, and you can literally just figure out each one of those, and you can see that it's going there. If you consider other points, like that square root of 2 over 2, that's pi over 4. And 3 pi over 4. So if you consider that, where those points are, and then think of, again, 1 over sign, you can calculate that point right there, and then literally you can just graph it, okay? But it's based off of the sine function. Well, the same thing with 1 over cosine, which is secant. So the cosine function starts at 1, and then it goes to 0, and then back to -1, and goes up like this. So again, I would suggest when you're graphing secant function that you graph this cosine function. And then it's just going to be literally the high point of this is literally the low point of that one. And the same thing with here. And again, the same thing with the cosecant, graph the sine function. And again, the high point is actually the low point of the cosecant function. So let's look at one more example. So what if I had 2 cosecant 1/2? Well, 2 cosecant, again, but it's based off of the sine function. Think of the sine function. So the cosecant is 1 over sine. So what I have graphed here in red is the sine function. That's the sine function. Now, I do want to notice that I want you to pay attention to a couple things. The amplitude is 2, so that's why I went up to 2 and down to -2. And then notice the period of the sine function is 2 pi divided by k. So down here, I have 2 pi over k, and then k happens to be 1/2. So I notice the period is 4 pi. So literally right here is 4 pi. So it's repeating itself from 0 to 4 pi, which means this is 2 pi, which means this is pi. And this would be 3 pi. All right, and that completes one period. And if you wanted to go another one, this would be 5 pi, and 6 pi. All right, and you can keep going on if you wanted to. So that's the sine function. Now remember, we're doing 1 over sine. And again, if you think of the unit circle, you can't have 0 on the bottom. I want to emphasize that you cannot have 0 on the bottom. So what you're going to be doing is just simply drawing your, let me do this in purple. So draw your vertical asymptotes here. Wherever sine is 0, that we can't have 1 over 0. So we know it's undefined. So those are my vertical asymptotes. And then all you really need to do, once you already found the period, you already found the amplitude. So the high point here is going to be the low point. And the same thing, the low point there is going to be the high point. And you're going to do the exact same thing on each one of these. And that's how you would graph cosecant. So again, notice the amplitude, notice the period, and I just did an example of cosecant, but the same thing goes if you go back to each one of these, the secant function, graph the 1 over cosine, graph the cosine function, and then it's going to be the exact same thing. The high point is going to be the low point. Keep in mind that, again, you can't have 1 over 0, so wherever there's a 0, where it hits the 0 is where you're going to have a vertical asymptote. All right, so that's the graphing of all the trig functions, all 6 trig functions that we've covered.